This video is on quadratic applications. We're going to do an example and answer these common questions that it asks. The example, it states that you shoot a basketball and its height in feet t seconds after leaving your hand can be found using the equation h of t equals negative t squared plus 6t plus 7. So this equation, without using a calculator, we are actually going to answer these questions. So the first question says, how high is the ball when it leaves your hand? We have to know what this is asking for. When it says how high, that's the y value because this represents height. Height is the y and time is the x. How high when it leaves your hand? So that's at the very beginning because we're shooting it. So when it leaves your hand, that's that y-intercept. The y-intercept comes from your constant term. So our y-intercept is at 0, 7. So to answer the question, how high is the ball when it leaves your hand? It was at 7 feet when it left our hand. That's our actual answer. So we needed the y value of the y-intercept, which was 7. And we put it back into units, so 7 feet. The next question says, how high, so again, how high means the y value, is the ball 1.5 seconds after it leaves your hand? So we're looking for the y value, but we're given the time, so that's our x, our time is equal to 1.5 seconds. So if it's asking for a y value at a specific time, we can substitute our time into the values for time. So we plug this in as the y value is equal to, so h of time is negative parentheses, our time is 1.5 seconds, squared, plus 6 parentheses, our time is 1.5 seconds, then plus 7. When we solve this out, we'll end up with our y value is equal to 13 75/100ths. So in order for us to put it back into context, it's asking how high. So the ball is at 13 75/100ths feet in the air. Yes, I did use a calculator to calculate this value, but I did not use a graph to do this. I did negative parentheses 1.5 squared plus 6 times 1.5 plus 7, and I did use my calculator to get that value. That is perfectly acceptable. On the next question, 3, it says when. So right there, I know that this is going to be asking for an x because time is when. This is an x. Will the ball reach its maximum height? So maximum tells us we're looking for the vertex. We want the x of the vertex. So in order to find the x of the vertex, we use that AOS formula of x equals negative b divided by 2 times a. So if we look back at our problem, we have negative times, our b value is 6, divided by 2 times, our a value is negative 1. So we have negative times 6 is negative 6, divided by 2 times negative 1 is negative 2, which is equal to a positive 3. So when will the ball reach its maximum height? So our answer is 3, but in context, it's 3 seconds. So 3 seconds, but it's after leaving our hand. After leaving our hand. Because it's not going to be 3 seconds after, and we're still holding it, but after we've shot the ball, 3 seconds after it's left our hand, that's when it's going to be at its maximum height. Question 4 says what? So that tells us right there that we're looking for a y value is the maximum height of the ball reaches. So again, that's looking for a vertex because it says maximum. So we want the y value of the vertex. We already have the x value. So if we have the x value, we can plug the x value into the problem to find our y value because the vertex is a coordinate, an x and a y. We have the x, we need to find the y. So let's plug in that x value of 3 into our problem. So we have that y value is equal to negative parentheses squared plus 6 times parentheses plus 7. We know the x value was 3, so we're going to plug in the 3 wherever we see the time. We'll have 9, so 3 squared is 9 times a negative is negative 9, plus 6 times 3 is 18, plus 7. So we have 9 plus 7 is 16, so this is equal to 16. So our answer is, what is the maximum height? So it's 16, the maximum height is 16 feet, because it's asking for height. We have to know what our units of measure is. So the maximum height it reaches is 16 feet. So our vertex is at 3, 16. 3 seconds after it leaves our hand, it reaches the height of 16 feet, because it's the same vertex. So our vertex is 3, 16. Question 5 asks, when, so again that's an x, will the ball hit the ground? So hit the ground. That's the y, or with the h of t in this case, is equal to 0. So we want to just set this equal to 0 and factor it. So we're going to take this problem. We're going to have 0 equals negative t squared plus 6t plus 7. Now we just need to factor this. So the first step is our GCF is equal to a negative, because that first thing is negative, so we always factor out a negative. And then our smallest number is a 1. And then all 3 of these do not have a t, so it's just negative 1. So we're going to have 0 equals negative 1 parentheses positive t squared minus 6t minus 7. We got to continue factoring this, so we'll have 0 equals negative 1 and then 2 sets of parentheses. So we have t times t would give us t squared, and then we know it's 1 times 7 would give us 7. So how do we get a negative 6? So is it 7 minus 1 or 1 minus 7? 1 minus 7 would give us a negative 6. And we have, so 1 minus 7 is negative 6. 1 times negative 7 is negative 7. So these are our factors. Now we're going to take these factors, anything with a variable in it, we're going to set it equal to 0. Negative 1 does not have a variable, so I ignore that for now. T plus 1, I'm going to set equal to 0. And t minus 7 has a variable, so I'll put that equal to 0. We'll get t equals to negative 1 and t equals to a positive 7. So I need the largest x value for it to hit the ground. So my larger number is 7. So the time also, have to remember, it can't be negative. I'm going to make a note about that. Time can't be negative. So we know that that negative 1 shouldn't even happen. It means that it didn't exist yet. So it takes, when will the ball hit the ground? It takes 7 seconds to hit the ground. So again, it's 7 seconds after leaving our hand for the ball to hit the ground. Our last question says when, so again, that's a x value. When will the ball hit the basket if the basket is 12 feet high? This tells us that we have 12 feet. The question is really asking x, when, y, or h of t equals to 12. So we're going to take that equation again, but instead of seeing h of t, we're going to put the 12 there completely. We're going to get completely rid of the h of t and put 12. So we're going to put 12 equals negative t squared plus 6t plus 7. Now, if we remember to solve this, we're going to solve this by factoring, same way we did here, but it has to be equal to 0 first. So we need to rewrite this by moving this 12, subtracting it to the other side. So this should become 0 equals negative t squared plus 6t minus 5. Because 7 minus 12 gives us negative 5. Now we're going to factor it. factor out that GCF of -1 again, because we have a -1 here, and then all of them don't have a t, so we know it's going to be 0 equals -1 parentheses, positive t squared minus 6t plus 5. Going to continue factoring the inside because there's 3 terms. 0 equals -1 parentheses, 2 sets of parentheses. We're going to have t and t. We're going to have 1 times 5 gives us 5, so I'm going to have 1 times 5. To get a -6, I need to do -1 and -5. -1 and -5 will give me a -6, and a -1 times -5 will give me a +5. So now we want to set these equal to 0, anything that has a variable with it, so -1 does not. T minus 1 equals to 0, and t minus 5 equals to 0. We get t equals a +1 and t equals a +5. So both of these answers are positive, but the question asks, when will the ball hit the basket? So after we've shot the ball up, we want to know when it will actually hit that basket. Well, that's looking for the largest x value, because it can't hit the basket 1 second after we've shot it up if it takes 3 seconds just to get to the highest spot. So 5 seconds is your largest solution. So that's when it would hit the basket. So the ball will hit the basket after 5, and our units is seconds for our time. The ball will hit the basket after 5 seconds. So we have to know what the question is asking. If it's asking for an x or is it asking for a y, and then how do we find it? So it might be asking for an x-intercept, which is what it's asking for when it hits the ground. It might be asking for the vertex when it says maximum, either one. Find the entire vertex, and you got both parts of your answer. Or it's asking for a very specific x value, which we solve by factoring, or it's asking for a very specific y value, meaning we plug in the number for our x. So it's really important that you know what the question's asking based off of the words, context clues.